This is a instruction over problems from Alex for college algebra, inferring properties of a polynomial function from its graph. So let's take a look at a problem. We'll go through how to work through it, and then we'll also look at another example to help you understand. So let's share the screen. Okay, so for these types of problems, one of the things the question will ask whether it's increasing or decreasing. And one of the difficulties with these problems is you really have to get all the parts right before it lets you move on. So we're going to go through this and make sure that get each part and understand it clearly. So when we're looking for the decreasing parts of the graph, what we have to do is we have to find these points, these turning points, because that's where it changes from increasing to decreasing. So here's one at -8. Here's one at about -4, we'll call it. Here's one here at +1, and here's one at 5, +5. So we're going to label these points here. This is -8, -4, 1, and 5. And now, since they're asking for where is it decreasing, we're looking for where the graph itself is coming down. So this part here is decreasing. And again, we started with increasing, then we've got decreasing, then we're increasing, and then now we're decreasing. And then it goes back to increasing. So there's two parts here. There's decreasing in this interval and decreasing in this interval. So this gives us from a -8 to a -4. That's one part where it's decreasing. And then this is going from 1 to 5. Those are the two decreasing parts and the only decreasing parts. So let's go ahead and mark those -8 to -4 and 1 to 5. That's it. Those are the decreasing intervals. Now the next question is going to ask the function has a local minima. Minima is minimum, the low points. So that's what we're looking for. And so we're looking at points like this. This is a minimum point. And here's another minimum point. What x values do they have? -4 and 5. So we want to list the x values where there are minimums. And if there's more than one, we need to separate them with a comma. So we can put -4, 5. That's all we have to list. Okay, so those are the two x values where we have a minimum. Now, had they asked for the maximum, we would have been looking for the high points, which would have been -8 and 1. So watch, these questions will switch back and forth between asking for either the minimum or the maximum. You need to make sure you're answering the right question. So what is the sign of the leading coefficient? Now for this, there are really 4 cases, 4 things that could happen. We'll go over this one first. So for when we have an odd function, which is one that looks like this. So it's a degree of, say, 3, 5, 7, odd exponents. So something like 2x to the 3rd power. If it starts coming from the negative, and then ends up going towards the positive y, this sort of thing is sort of what we would consider normal. It's a negative x's are coming from negative infinity, and then positive x's are shooting up to positive infinity. This is what a positive leading coefficient would look like. The other one is if we come from a positive, come here in the middle and go down, shooting. So here the positive x's are going to negative infinity. That's what we would have a negative leading coefficient. So notice like -2 would be our leading coefficient here. And this is for all types of odd exponents. So what we have here is we come from negative infinity from the y direction, right? This is negative infinity. And we do our thing, and then we shoot off to positive infinity. That is this case here of an odd with a positive. Okay, so we're going to select positive. Need to get a larger tablet, I think. It's harder to, okay, so it is positive. This will either always be positive or negative. You can't have anything in between. Now, had this graph come down this way, did this, and then went back down, that would be the negative. Okay, while we're here, let's just talk about it. The other option is if you have an even function, even exponent, something like 2x squared, evens always give you a U shape. And so if it's a U shape up, which is like a smile, that's a positive, and a U shape down, that's going to be a negative. So that would have been -2x squared. We might see that in the next one, hopefully. Okay, so far we just have one thing left, and that's to determine what the possible degree of this function is. So let me clear everything else off. There we go. Let me come up a little bit. Which of the following is the possibility for the degree of f? So first, we've already decided, because of this shape that's coming from negative and going to positive infinity, down and are coming up and then going off this way. This is an odd function. So it's either going to be 5, 7, and 9, and so forth. It's going to be the odd numbers. The way we count that is we keep track of these turning points. So we've got 1, 2, 3, 4 turning points. And then we could add one more, so it's at least a 5. Okay, so notice 1, 2, 3, 4. So turning points, plus 1. So we count, here's 1, 2, 3, 4. So 4 turning points plus one more. It has a degree of at least 5. So what we can do now is we can check the box for 5, but this is sort of the minimum. There could be a hidden 7th degree or a 9th degree. We always have to get those. Okay. The other way, which is going to give us the same answer, but just kind of depends on how you want to look at this. You can just count how many times the direction sort of changes. So I could say this is 1, 2, 3, 4, 5. There's my answer. I could get the 5 that way. So if you don't think you're going to remember to add the 1, you can just count how many times, kind of bring your finger across it. So there's 1, 2, 3, 4, 5. Okay. And that will give us our answer. Let's go ahead and check it. Make sure we got it right. And we do. So let's go through this next one more practice, maybe a little quicker, or let's see what they give us. Okay, so notice this one, they've given us an even. It comes down, it's sort of this U shape. In between it does all this other stuff, but it's an even function. Okay, so let's just walk through this one and then we'll have it down. Of course, if you're got it, you want to go on to the next, that's fine. You could stop watching this video at any time. Okay, so first of all, what I want to do here is I want to mark the places where we have sort of the turning points. There's one, there's another. So these are going to give us our max and mins as well, but it's the places they change direction at. Okay, so a little sloppy, but you'll be able to tell, right? So here we've got this is -4, 5, so this looks like -6. This is -3. Here's a +2. This is 5. Wait, 4, 5, 6. That's 6. So that's the other thing. You got to really be careful with these because one little misrating will get you a wrong answer. And then this is 9. Okay, so we're looking for where the function is decreasing. That means going down. This part is decreasing, then we increase, then we decrease, then we increase, then we decrease. Finally, it increases. So there's 3 places, 3 intervals of decreasing. So from -infinity out here until -6, that's one of them. From -3 to 2, that's another one, interval of decreasing. And then going from what this was 6 to 9. And just remember, out this way would be positive infinity if we need to. So we can mark those intervals down here. -infinity to 6, -3 to 2, and then 6 to 9. Function f has local maximums, maxima at which x values. So where are the maximums? Again, we're looking for the tops. So local maximums are just wherever we're going to see sort of the top of a mountain. So here's one, that's a minimum. Here's a maximum, that's a minimum. So there are 2 of them. So -3 and +6. So those ones we go ahead and list in here, -3 to +6. The sign of the leading from the last one, notice it's a U-shaped up, so it's going to be positive. And then for the last part, let's clear all this off. How many turning points? 1, 2, 3, 4, 5 plus 1 makes it a 6. And it's a minimum of 6, so that means it's 6 or 8. It's an even, and there we go. We check that, and it says we're correct. So give that one a try. Hopefully this will help. And that's it. Thanks.